it's about memory. How computers store memory. So computers need memory to store stuff. You know, like in those gates, when you get the output, you just throw the output away and you don't get it back. Well, in RAM stands for random access memory. There's another type of memory called persistent memory, which can stay if you pull the electricity wire out, but RAM needs electricity to work. So the simplest thing is basically the OR latch. It's basically a one inputted latch. So let's see how this actually works. So in the beginning, so let's say that you set A, which I guess is the only input, so let's call it input. So let's say you set input to 1. So you might be like, hey, why is this B, like the second input in the OR gate, it's not coming from anywhere. It's recursive. Yeah, that might be true, but let's assume it's 0. The current is always 0. And so when you OR 1, 0, you get 1, and 1 loops back around in the OR gate. And then 1 more 1 is 1, so that still goes to the output. And when you put the input back on 0, there's a problem. It's still on 1. You can switch the input no matter how you want, but the output is always going to be 1. With the AND latch, the problem is the opposite. It's always 0. If you set the input to 1 this time, it doesn't turn on because the other thing is 0. The other input of the AND gate is 0. So that's wrong. So we move on to the AND OR latch. So the AND OR latch is a combination of those two latches, and so it uses a set and reset wire. So you OR is set with current, and you invert the reset. So you AND it with the result of the OR gate, and that becomes the new current and output. But having 2 wires for input is actually confusing. So the gated latch is basically an add-on to the AND OR latch. So use a NOT gate and 2 AND gates to be the set and reset for the AND OR latch, also known as an SR latch. A register holds multiple bits. So use multiple gated latches. So this is a register that can hold a byte or 8 bits. So it has a shared write enable, and that's what the E is. And there are a bunch of datas that you can set. So you can set those data wires, and if write enable is 1, then you can actually write the data into it. That's why it's called a write enable. You can write the data and it will come through Q, the data out. But it turned out that 8-bit, not 8-bit, but as you get more and more bits for register, you get a lot more wires. You're already using 17 wires because 8 times 2 is 16 plus 4 is 17. And if you actually needed to do a 16-bit register, you'd need 33 wires. And for 32, you need 65, and for 64 you actually need 129, and for 128 you need 257, and for 256 you need 513, and so on. So there's going to be a lot of wires. So you probably want to lay the registers in a matrix or grid. So you actually, and the row and column, because both of those need to be set to true for this cell to be the correct. And that's the row and column select test. And we add that to the write enable, which is the overall write enable, and the read enable, which is the overall read enable. And the data, it could either be going in and out. The data would be going in if you're writing and out if you're reading. So this picture, Crash Course's picture about this, they didn't actually show that write enable is always the opposite of read enable, but I guess this could be how it works, but it does actually make that much sense. So you pass that into the gated latch, and the overall read enable, well, if that actually is true, then the current, then it actually gets passed through a transistor, and the output of the gated latch is the current, and it gets sent to data out. So this is one of the cells of the matrix, but how do you actually select these rows from a number? So this is so let's say that this is row 12 column 8, or actually I think in the video it might have been, I knew it was 8 and 12, but I don't know which order it was. But okay, so it was based on a 4-bit number, but how do you pass in a 4? But how do you use a circuit to pass in a 4-bit number and give out an electrical signal? What you use is called a multiplexer. So the column address is 4 bits, and it takes in 4 bits and it can output 15 electrical signals. 16, because there's the 0 one. And this is actually how you would align it. So if you follow my mouse, you'll see that down here from 8, you'll see 8 to 12. And that is column 8, row 12. And this is actually this is also an 8-bit register, but it can actually store 256 bytes instead of 256 bits. And it doesn't store 8 bits either. So it sends an address which is 8 bits, 4 bits for the row, 4 bits for the column, and there's a write enable and a read enable. This looks a lot like this looks familiar because it looks like the register we saw before, except with an address, because you didn't need the address before. So just looking at that register as a register of 8 256-bit memories. We'll look at it as a lot of lines that we can write binary into 256 lines to be exact. It takes an 8-bit data, an 8-bit address input, a read enable and a write enable, and right now there's not a wire for, oh, actually there is, it's the 8-bit data. Well, we'll be building our CPU in the next episode. So for now, bye! Thanks for watching!